Good morning. My name is Joe Ackerman, and I'm a biosystems engineer, research associate at the University of Manitoba. And this is a video of a talk I gave this week, which is July 2024, at the Canadian Society of Biosystems Engineers, held in Winnipeg. It was a plenary talk on the topic of wicked problems. Engineers deal with wicked problems. And so after some requests, this is it in video format. So let's begin. Plastic is the king of wicked problems. What is a wicked problem? Wicked problems are ones that are more than just devilish, thorny issues with no easy solution. Often they're a symptom of another problem, and solutions tend to produce new additional problems. Unlike a tame problem, there is no immediate and ultimate test for a solution. You don't really know when you've answered it. But due to their complexity and overlap of different kinds of systems and things that are influencing your problem, often it's characterized as having organized irresponsibility. So all these things together means there's inherent resistance to any solution. So how does plastic fit into this? Production. Production of plastic is like a runaway train. Here's a graph of all the plastics ever made. And well, right now in 2024, we are at about 9 billion tons. So everyone on the planet gets, a little bit more than a ton each. A lot of this has been buried or burnt. Some has been recycled. But it is the annual production. Plastic production has grown at about 8.5% growth rate since 1950. And it appears to be continuing about that. And so right now we're making about 800 million tons per year, of which half is packaging. So that's sort of the state of production. Why? Why are we making so much plastic? Well, because it's cheap. It has infiltrated pretty well every part of our life, and it has successfully replaced paper and cotton and wool and leather and wood. Many organic materials have been replaced by plastic. And if you just step back or sit down and look at what you're wearing right now, what you're touching, what you're sitting on, what your shoes are made of, what's in your hands and your pockets, just where you are, look at your environment. How many things are plastic? Some variant of plastic. Likely most of it. Maybe all of it, at least some of it. I have a little side project of finding toys for my grandchildren that are not made of plastic. It's an interesting challenge. I seem to be pushing them towards life in the trades or something like that. So, is there any problem with this? Well, two things I'm going to identify. One is climate change. Since most plastic is made from fossil fuels, more production means more fossil fuel extraction and eventual burning of it, or goes back into the system in some way, often as CO2. But the other one is microplastics. Now, I began studying microplastics about 4 years ago, and at that point, microplastics were found everywhere. Everywhere scientists looked, they found them. So any body of water, any mountain range, any pole, there was microplastics. You look into food. At that point, they had looked into salt and beer and mussels. They looked at house dust, and just everywhere they looked, well, there's microplastics. Were they bad for us? Not really any conclusive studies. Probably not good for us. Probably inert. That was kind of consensus, but we should keep studying it. Well, we have kept studying it, and the study has enabled us to detect it in environmental samples, so things you actually find out in the wild, at nanoscale particle size. So we went from like 50 microns, like width of human hair, or actually, fibers that you might pick out of your wash cycle, to now things that are, much smaller than bacteria, and can cross the barriers into your cells. So they've looked in the human body, and found it everywhere they've looked in the human body. So found it in lungs and in cells and in blood and in the brain and in fetuses and in testicles. Has it been proven to cause harm? Well, yes, it has. The plaque in your arteries has microplastics in it. And the more microplastics in your plaque, the greater the risk of heart attack. So harm there. Testicles. The more microplastics in your testicles, guys, sorry to say this, the lower your sperm count. And sperm count is a serious thing. Sperm count between 1973 and 2011 went down 50 to 60%. Went down 60%. That on a global scale. So that's not even including the last 12 years. So it's not likely getting better. So that's serious cause for alarm. This slide here actually shows you a QR code link to a little film about microplastics in the home. Take a look if you haven't. So what's the answer to this? The answer is probably not recycling. Sorry to say. Recycling plastic can extend its life by, if you're lucky, 3 or 4 times. You can get about 3 or 4 cycles. Each cycle of grind and remelt, you lose all the features that you want in your plastic, no matter what they are. If you want flexibility, you lose it quite dramatically. If you want tensile strength, you lose that. If you want clarity, you lose that. So each time you recycle plastic, it goes down in quality to the point of it's not really useful at all. It's going to just be a brick now. But most plastic is not recycled even once. In the US, 5 to 6% at last count was recycled of annual production. Globally, it's about 9%. So, why is that? Well, there's problems. Collection problems, sorting problems, contamination problems. There's problems with scission of polymer chains due to radicals produced during extrusion process. There's a lot of problems. But you might say, wait a minute, I've been recycling since the 80s. Haven't they had time to figure out all those problems and address them? Well, this is a very good point. And this brings us to an interesting report called The Fraud of Plastic Recycling. It's worth a read. It's not as shrill as it sounds, and there's actually some very good investigative work done in it. From this report, I found out that the American Plastic Council said within 2 years, 25%, there's going to be 25% recycled content in all new plastic products. Wow, that's fantastic. Hallelujah. But then you look at when that statement was made, and it was made in 1992. So this deadline that they set themselves for quietly came and went. And here we are 30 years later, and there's still equivalent councils making the same kind of statement. What this report exposes is a very long-term, 40-year effort by plastic manufacturers to front-run and stall any legislation and restriction on production of plastics or on mandating recycled plastic in products. So they've been fairly successful at this. But there are problems with recycling. it's not, the problems I outlined are quite real. Most people don't realize that recycling plastic is gathering it, grinding it up, washing it, doing some kind of float sink method, separate the polymers, then drying it, and maybe doing a little bit of near infrared to further separate the polymers, and then melting it. And there's problems with that. We've gotten good at some of those, but usually it takes equipment, and it's expensive equipment, and it's the only time it's economical to do all this is when the size of your plant is really very large. So in a small place like Winnipeg, which is where this talk was given, we have to ship our baled plastic 2,000 kilometers to have it processed in this way. So all the way to North Carolina or Toronto or probably Vancouver. Well, that's adds to the cost unbelievably. So it lowers the value of your material, often to a negative point. And a negative value means I'm going to bale up plastic that I've collected, and I'm going to give it to you, and I'm going to give you $50 also. And then, so you have a lower grade product that it has pretty heavy subsidy going along with it. And the trouble with that is anytime you want to make something disappear, and that's how we treat our waste, we just want it to please disappear, and you put $50 with it, then the mafia steps in, and they're happy to make things disappear. They're good at that. So what ends up is someone has taken it from you, and it's a very opaque system. The value chain is very, very hard to find, and you don't really know where your bale of plastic has gone to. Nobody really keeps track of it, and often it ends up on a beach in Indonesia someplace, just dumped. If your plastic does successfully make it to a recycling facility, it's likely making a lot of microplastics there. A recent report from the UK looked at a brand new recycling facility taking like 22,000 tons a year. So that's a medium-sized recycling plant. And they did the measurements of the wastewater going through the plant and determined 13% of the entire annual throughput of the plant ended up as microplastics in the wastewater. And 90% of that was 10 microns or less. Now they say that this is still an underestimation because they couldn't measure anything below 1.6 microns, and they didn't measure any airborne microplastics. A filter put onto their system reduced it by about half. But this is a new facility. It's not an old rinky-dink, clunky one. So that's kind of a shocking thing to think that you might be producing more microplastics in your efforts to recycle. So what do we do? I don't like to leave people with no answers because I think there's, that's part of the fun of all this is, what do we do about it? When I was in the Netherlands this last winter, interviewing people on plastic packaging, experts over there, I met someone who asked the question, all of these initiatives to fix the system, to fix the plastic pollution problem, how do we differentiate one over the other? What's a better system than another? So they took all of these 54 current, popular, interesting, dynamic initiatives and grouped them into, this is about plastic design, or this is about plastic use, collection, sorting. So they listed them all, 54 of them, and then ran them through a criteria of ranking. And these were these criteria you could put into 3 different groups. Basically, circular economy principles, which you've got things like, does it lower fossil fuel consumption? Are climate goals fulfilled? That sort of thing. Implementation, is there demand? Do regulations and technology already exist for this? Then long-term circularity, contribution, how scalable is it? Like what's the impact? Like, is this a small idea or a big idea? Like, what's the impact on the greater system? And putting it all together with this ranking, all of these ideas, you get a chart looking like this. And if you look at what makes it to the top, here's extended producer responsibility of packaging. So basically the same thing as has been instigated for like large refrigerators or something like that. Oh, let's extend that to packaging. So the producer actually has skin in the game about what happens to it. Lightweighting, then things that kind of didn't really come out very strong was, oh, there's some pyrolysis initiatives, some sorting initiatives, and then there's collection. Anyways, it's a very interesting read, and to see where your favorite initiative or save the world idea, where does that land on this? How about me? What's my favorite save the world initiative? Well, I think the root of the problem is actually overconsumption. I think whatever human quality that is based in, that is the thing that has to be addressed, both on a personal level and also on a large systems level. Because we just want to make things disappear. We want to consume and we want to throw it away. And that's a big part of where the problem comes from. I want to close with this interesting photo. This is something, two photos I took in Turkey where I was this last winter. And one is cheese in a goat skin, and one is butter in a cow intestine. And these photos were just taken in shop windows in Afyon. And all of the barrier properties that these two materials have are the barrier properties that plastic is actually trying to synthesize, where you have, you keep moisture on one side and you let some gases through and not other gases through, or I'm not even sure of what the barrier properties are. I'm not a materials expert. But the butter, the shopkeeper said, oh, the butter can keep for 6 months in the cooler, like this. I bought some of both, and they're both excellent. It wasn't that long ago that we didn't have any plastic at all, and we did just fine. And we could go back there. We could count plastic as a failed experiment and just go back to the way we were doing things before. Anyways, that's my talk. Here's my list of references. If you want to look up any of the papers that I have referred to, they should be all in here. And, well, when you're at a talk, you can ask for questions, and I'll do my best. If you want to put questions in the comment section, I'll be happy to go at them, or someone else can. This picture, actually, by the way, since I have your attention, is a tiny experiment I did, taking polyethylene film and basically just incubating it for about 6 or 8 weeks with bacteria and some nutrients. No other carbon source. And this is, you can see 5 microns is the scale here. So this is basically, oh look, we have microplastics. It just flakes off. This hasn't had enough rough treatment for them to all flake off, but I put that in here to see, like, it's that easy. Okay, well, thank you very much. This has been fun, and we'll see you next time.